Hey students, we are doing lesson 10.6 here. We're going to learn some right triangle trig. So we're going to learn how to find and use trigonometric ratios. Go ahead and do this vocabulary just to remind yourself about what ratios are. All right, here's a key concept. Sine of angle A, the sine of A is the side that includes the ratio that includes the opposite leg over the hypotenuse. Cosine is the adjacent leg divided by the hypotenuse. And tangent is the opposite leg divided by the adjacent leg. Now, some of you might be confused with those for a little bit, but it won't take you long to get to know those. In every right triangle, there's one right angle. The longest side, of course, is the hypotenuse, so let's label that first. And I always think in terms of the hypotenuse, what else do you have? Okay, now we're talking about with respect to angle C, so we're trying to figure out which side is adjacent and which side is opposite. You guys know what opposite means. Adjacent means next to. So now angle C, the side that's next to, is this one. So that's the adjacent side. And then this would be the opposite side. In the other diagram, the green line here is the adjacent side to angle C. And the blue line is the side opposite. So kind of get used to doing that so that you can identify these trig ratios. So we want to know what the sine of A, the cosine A, and the tangent A are. For a while, you may want to just write them down, what they mean. If we're looking for the sine of A, we're looking for the side opposite over the hypotenuse. Now, the hypotenuse is obvious. And the side opposite angle A, so here's our angle. The one next to that would be this 15, that's the adjacent. The one across is the opposite. So we're going to do 20 over 25, and then just simplify that to 4/5. Now to do the cosine of A, we want the side adjacent to A divided by the hypotenuse. So the hypotenuse is the same. The side adjacent to A, we just talked about that. That's this part right here, right next to A. The leg there. Now remember always the legs are the opposite and the adjacent. The hypotenuse, of course, is the longest side. And then the last one is the tangent of A. And the tangent of A is the side opposite A divided by the side adjacent to A. And with respect to A, the side opposite is 20. The side adjacent is 15. And then we just want to simplify those. That would be 3/5, and this would be 20 divided by 5 is 4, 15 divided by 5 is 3. So those are the ratios. And I might just say here, just quickly, the idea behind trigonometry is that if you have a right triangle, so let's say here's our right triangle, and let's say this angle right here is 30 degrees, then the ratio of the sides of that triangle, since this other angle has to be 60 because all the angles add up to 180, the ratios, any other triangle, right triangle with a 30-degree angle, will be similar to that triangle. And similar triangles, similar objects, by definition, have equal ratios of corresponding sides. So, like if I say x over y on this one and a over b on this one, x over y will equal a over b. And since we know that they're all going to be the same, we can just program a value for that ratio. And so when you push the button on your calculator that says tangent of 30 degrees, it gives you that ratio. So what are the sine E, cosine E, and tangent E for the triangle, right? Go ahead and see if you can figure it out. I'll pause here. And all right, how'd you do? Okay, one thing we can do, since all these ratios are going to be the same if two angles have the same, two right angles have the same other angles, they're programmed in your calculator. And so if you enter the degree, change your calculator degree mode and enter the sine of 39 degrees, it'll come up with a number. So what we're looking for on your calculator is, it'll look like this. Sine of 39 equals, and so just turn on your calculator here. So here's your calculator, and the first thing you want to do is check the mode button right there. Make sure that your third thing down is reading degrees, like that. Then all you have to do is find the sine button, which is right below the app button. And then it allows you to put in any number you want, and that is the measure of the angle. Press enter, and you get a value. In this case, 0.6293. So, and we're going to have to go approximately because this is not exact, but to the nearest 10,000, 0.6293. All right, so using that information, we can find the missing side. All we have to do is identify the trig ratio that is used here, and then use our calculator to help us find those values. So notice with respect to the 71-degree angle, we have a hypotenuse, and we have a side opposite that we're looking for. So the opposite over the hypotenuse, that's the sine. And in this case, it's the sine of 71 degrees. And the side opposite is x, and the hypotenuse is 20, so we can just say x over 20. Well, this is really two ratios here. So we can say x times 1 is equal to 20 times the sine of 71 degrees. And then I'll just go to my calculator and do 20 times the sine of 71. Enter. And it gives us about 18.9. Rounding to the nearest tenth, we would say x is equal to 18.9. Now just do a visual check there. It has to make sense. This number has to be smaller than the hypotenuse, so 18.9 is good. All right, I'm going to let you try that. See if you can pick the right values to put in there and solve that. All right, how'd you do? One thing you got to make sure is make sure your calculator is in the degree mode to do this. All right, one other thing you can do with your calculators is you can use the inverse function to find the measure of an angle if you know the ratio. So the inverse function takes the ratio and turns it into an angle. And so if you know two sides of a right triangle, then you can know all the angles of that triangle, and I'll demonstrate that here with one of these problems. So number 33, it says the hypotenuse is 8 feet long. So let's just draw a quick triangle here. And let's draw in that the hypotenuse is 8. The adjacent side is 5. So when we're talking about adjacent, we're talking about with respect to this angle right there. So we'll say angle x. And so we have adjacent and hypotenuse. Well, that's the cosine. So the cosine of x is equal to the side adjacent divided by the hypotenuse. And in this case, the adjacent side is 5 and the hypotenuse is 8. So let's just write that. And 5/8, we can just divide that and make that a decimal. Cosine of x. Now here's where you use the cosine inverse. So we want to know the angle here. If the cosine of x is equal to 0.625, then the cosine inverse of x, of 0.625 is equal to x. And so on my calculator, what I'm going to do is press second cosine, put in the ratio, 0.625, and the calculator will give me the degrees, which is about 51, let's say 51. So x right here is about 51 degrees. Well, now we know all the angles because the three angles of a triangle add up to 180. So if we know that this one is 51, the other one is just 90 minus 51, which is equal to, I hope my math is right there, 39 degrees. Let me do one more here with you. We'll do the bottom one here. It says the hypotenuse is 6, the opposite side is 3. Draw a quick picture here. Hypotenuse is 6, opposite side is 3. If we're saying this is the opposite side and that's the right angle, then we're talking about this angle right here. And opposite and hypotenuse, that's the sine. So the sine of x is equal to 3 over 6, which is, of course, 1/2, 0.5. And so to figure this one out, we're going to do the sine inverse of 0.5 will equal x. So on my calculator, I'm just going to do second sine 0.5, and that equals 30. So x is 30 degrees. So in this problem, we know that one angle is 90, one angle is 30, so the other one has to be 60. So that's how you use the sine inverse. Sine angle. All right? I'll let you try that. All right, one more thing. Suppose a plane takes off at an angle of 42 with the ground. What horizontal distance has the plane traveled when it reaches an altitude of 30,000 feet? So let's just make a little drawing. So here's the ground. Let's say the plane takes off here, starts flying like that, and at an angle of 42 degrees. And when it reaches an altitude of 30,000 feet, that would be this distance here. How far has it traveled when it reaches, and what horizontal distance has it traveled? So not the arrow going up, not the hypotenuse. We want to know the bottom there. Now, here's your right angle. Here's our angle. 30,000 would be the side opposite, and D would be the side adjacent to that 42-degree angle, which gives us a tangent. And tangent is opposite over adjacent, which is 30,000 over D. So using our cross products property, we get D times the tangent. Oops, I forgot my 42 in there. Tangent of 42. D times the tangent of 42 is equal to 30,000. So D is equal to 30,000 divided by the tangent of 42. Use the calculator to get that. 30,000 divided by tangent of 42 gives us 333. Whoops, I put an extra 0 in there. I think that decimal would just be moved back one. So about 33,318 feet. So this 33,318 feet is our answer. All right, I'll let you try that. I'll give you the answers, and that'll be the lesson for today. And the lesson check. See you tomorrow.